We're looking at equations. We assigned an equation summarizes a chemical reaction. Summarizes a chemical reaction. So here we have looked at gases, how to prepare a gas, how to do that, the reaction, and so now we're looking at equations. How do you write equations? So summarizes a chemical what? Reaction. That is step one. But I will say that one of the key things we must know that a chemical reaction has two parts. Chemical reaction has two parts. So what it is reacting with, what we call the reactant C over there, that is one. Then two, what it is forming, what we call the what? The products. That is two. That means these ones, they will be in what we call what? A chemical equation. That means if I have A plus B giving us this arrow, means there's something being formed. So it must be that by the way you write the arrow must be properly drawn like that. Not these arrows. There are some people who draw arrows, then they live in space. Please, the arrow must be attached there, giving us C and what? And D. So most of you know this, but I'm giving a recap of what we covered. Now, these are what we call what? Reactants. And these are called what? Products. So, yes?
Have you shared another screen?
And see that now.
Now it's okay.
Okay, so that means the equation, that's an equation. So an equation summarizes a chemical what? Reaction. Out there. Then we have said the chemical reaction has two parts. It has the reactant side having the reactants. It has the product side having what is formed. And so we have an example here. If I have A plus D, this arrow shows us what is going to be formed. It's like a pathway. And so then C and what? D. So C and D are the products. Then A and B are the what? The reactants. Now there are some things we must know in every chemical reaction. There are some things we must know. One, what are you reacting? What are you reacting? Out there? So what are you reacting? So those are now under the reactant. Also, maybe it is an acid, maybe with a base. Maybe it is a carbonate with a heat or with oxygen. A metal, maybe and chlorine. So what are you reacting? Also, so in what we are reacting, we are looking at now two things. Are you looking at the elements C that are reacting, or you're looking at the compounds which are there? Or the ions? We can have ions specifically. We looked at that under ionic equations. Then those are the elements, products, or ions. Then two, out there. Two, what are the conditions for that reaction to take place? What are the conditions for the reaction to take place? So maybe magnesium and that, what are the conditions? Either you heat, or maybe room temperature, or maybe a catalyst, maybe temperature, all those are the conditions now. Then three, what are you forming? So what are you forming now? Remember, what you are forming is what we call the products. So what are you forming? What is your target? What are you forming? So these are what we call the products. So after that, we look at now balancing. So is your equation balanced? So equation is balanced. So is your equation balanced? Now, the importance of balancing the equation, it shows us the correct ratios or proportions. Shows us the correct proportions needed. The correct proportions needed for that agenda to take place. So when I say, what are you forming? Those are products. Equation, is it balanced? Because when it is balanced, it shows us the correct proportions or the correct measures that we need, either 20 grams and that or 60 grams, depends. That's now under moral concept. So equation is a very key thing to note. Then what are the steps needed for that to take place? What are the steps taken? So NB, steps taken to write an equation. Step 1, you must know the formulas of a specific compound, or you must know the symbols. I mean, step 1, you must know the symbols over there. Maybe, for example, I'm looking at the sodium atom, which is Na, capital N, small a, comma, magnesium is Mg, copper is Cu, aluminum is Al. Those are the symbols now. Then the two formulas. Now, formulas, remember, we get them from compounds. Maybe calcium carbonate, which is Ca with a carbonate. That means you must know the valencies of these what? Of these products there. You must know the what? The valencies of those products. Let me just, this is calcium carbonate. That's the formula. Maybe I'm looking at sodium oxide. That's the formula. So those are now what? Formulas. That means, where are they from? They are from the valencies. That means you must know the valencies of these what? Of these products. So those are now what? Valencies. For example, copper has a valence of 2. So when I say copper to chloride, you know what you're forming and the correct formula there. That means chlorine has a valence of 1. So maybe magnesium has a valence of 2. I think we know how to get those valencies. So are we together so far?
Yes.
Okay, very good. Denise, are we together?
Yes, sir.
Very good. Now the next thing we are going to look at, we're now trying to form now an equation. So we have the very example here. Let me share this with you. Let me share this. Are you seeing that one? Are you seeing example 1?
Yes.
What is that one? You read for me, What do you read there?
Air burns in air to form sodium.
Sodium burns in air to form sodium peroxide. Also?
Sodium peroxide.
Now, what have they said? They said the sodium, that's now a chemical reaction now. Also? So chemical reaction 1. So they say the sodium over there burns in air to form sodium peroxide over there. But remember, when we say sodium burns in air, what is it reacting with it? I mean, sodium will be reacting with oxygen, because in air we have very many gases there in air. We have carbon dioxide as a gas. We have oxygen as a gas. We have rare gases. There are very many. Those are noble gases now. Noble gases. They are there. Helium, krypton, all those are noble. Then we have nitrogen. Now, among these gases, which one supports burning? Which one is supposed?
Oxygen gas.
Oxygen gas. Therefore, sodium will be reacting with oxygen. But remember, we are saying we are using the formulas and symbols. That means now the symbol of sodium here is what? Na. Now the other thing we forgot is the state symbols. Now sodium has a state symbol of solid. Over there with S. That means sodium is a solid. Then we say state symbols needed. State symbols required. That means if a substance is a solid, we shall say it is S. That's the set symbol now. Then if a substance is a gas, it will be what? G. Over there. If a substance is a liquid, we shall use small l. Over there. Now, if a substance, when you have a solution, it will be now aqueous, which is H2. We shall say it is what? An aqueous solution. A what? H2. That's all. So all those basically that. So that means when I have here now sodium is what? Sodium is a solid. So sodium Na is what? It is a solid S. Burns in air, oxygen, so it will be a gas, forming sodium peroxide. Now, we said we must have the conditions now. If you're going to form sodium peroxide, you must be with excess oxygen. It must be with excess oxygen. Therefore, we shall have sodium, that is solid, plus oxygen O2, which is a gas. Now you must put this arrow here to tell us what is being formed. Also, but remember, from what I see here, I have sodium with the valence 1, oxygen with the valence what? 2. And so we are using the oxygen atom only. So that when this one comes, it will exchange what? The valences, so having sodium 2 and that. But our oxygen is in excess. That's the condition for peroxide. That means the condition here, is excess oxygen. So this, or then we just put a 2 here in case of excess oxygen. Now this is the formula of sodium peroxide. Now, this is what we call now an equation now. But remember, it must follow all steps we have seen. Is it balanced now? Now the third symbol is a solid. The third symbol is what? A solid. So therefore, we shall say Na solid plus oxygen gas. So O2 solid. Then on balancing, I have this over there. There are 2. This one is also what? 2. I think that one is balanced. Is it balanced?
Yes.
Very good. So that is the number 1 equation first. Let me hope you have known the steps. Any questions so far? No. So the condition is excess oxygen. Over there, that's the condition for that reaction also. Excess what? Oxygen. Let us look at example 2. Example 2. Example 2. Example 2. Are you seeing that one? Example 2 is our number 2.
Yes.
Are you seeing our number 2?
Yes.
It says magnesium burns in air to form magnesium oxide. So magnesium burns in air to form magnesium oxide. So try for me that one. So try for me that one.
Teacher, what's the condition needed?
The condition for that process or reaction is there. Remember I said magnesium burns in air to form magnesium what? Oxide. That means when you're going to burn magnesium in air, we need heat. It must be there. That means air, even if air is limited or in excess, oil can work, but heat must be there. So condition is heat. So heat and what? Just oxygen gas. Denise, are we there?
Yes, sir.
Okay. So therefore, we have magnesium. The symbol is Mg. Out there, magnesium is a solid. So that means we shall say the test symbol is S. Is a solid. Out there, burns in air. That means it's going to react with oxygen gas O2 out there. So this one is a gas. Forming magnesium oxide. That means magnesium has a valence of 2. Even oxygen has a valence of what? 2. So when you swap these valences here, we shall be getting magnesium 2 and O2. But these have the same denominations, so you can cancel them out. So you're having magnesium and O2 like that. So this one is a solid, it belongs to the oxide Z. So it is an oxide, which is a basic oxide. This one is a basic oxide. I think look at oxides. So it is a basic oxide. So it is a solid. Therefore, we shall have magnesium Mg bracket solid, that's a set symbol, plus oxygen gas out there, giving us magnesium oxide, which is also what? A solid. Now, is it balanced?
No.
So how do you balance that one?
We put 2 on magnesium and 2 on magnesium oxide.
Very good. So you shall put a 2 here on magnesium oxide and 2 here on what? Magnesium. That's very good. Now the condition, we have said the condition for that reaction to take place, we must have heat. So condition for the reaction is what? Is heat. Out there. When we come back here, remember one of the things we emphasized under chemical equations. Let me see. So we said, so reactants, we have the reactants. What are you reacting? That and that. Condition for the reaction, what are that? What are you forming? We saw that. Is the equation balanced? That. Very good. Let us look at example 3 now. Example 3. Example 3, I'm going to choose it from some. Example 3. So, example 3. So we come here. Let me see. I see number 26. Example that 26. I think 26. It says what?
Yes.
What are you saying?
Hydrogen reduces heated copper to oxide to copper and is self-oxidized to water.
Now we are seeing some new words there, isn't it? Hmm?
Yes.
We are seeing hydrogen reduces heated copper to oxide, isn't it? Eh?
Yes.
What do you think the condition is now? Look at the statement. What do you think the condition is? The condition is heat. That means copper must be heated. Out there? Copper must be what? Heated. That means hydrogen reacts with the heated copper to oxide to form copper, and itself oxides to what? To water. So what do we have? So we have this. Let me summarize this a bit. Therefore, I've said the hydrogen is a gas. So hydrogen reduces over there copper 2, which is heated now. Is heated copper 2 also. Copper 2
Yes.
oxide to form copper. And to form copper and itself oxidized to water. Now, if you look at this, hydrogen is a gas, not so? So that means I have H what? H2, it is a gas. What do you think the third symbol is? It is a G, not so? Now, reduced or reduces, it means we are undergoing reduction. We are undergoing what? Reduction. Then, but we said these are key things you must note. NB. Reduction is loss of oxygen or removal of what? Oxygen. Of what? Of oxygen. That means when you remove oxygen from maybe a compound, you are doing what you call reduction. That means that element or that atom is reducing that. Then when you say itself oxidized, that means it's undergoing oxidation. Oxidation is the same as gain of what? Of oxygen. We have various definitions of oxidation. I think some of us will know them. But I'll not go into that now. We're mainly focusing on equations. So then I say hydrogen reduces that. That means I have hydrogen as a gas. Then the formula of copper to oxide. Copper has a valence of 2. Oxygen has a valence of what? Of 2. So when these two swap and they swap, we shall be having copper 2 here, oxygen what? 2 there, which will be reduced to copper to oxide, something like that. That's under formulas out there. So copper to oxide and itself oxidized to water. That means water, we know the formula of water. Also. So step 1, reactants. What are the reactants I have? I have hydrogen gas. That's a set symbol. Plus copper 2 oxide, which is a solid out there. So now this arrow must be there to show what we're forming. Now forming us what? They said it forms copper. So copper is just Cu. Copper is a solid out there. Plus C, now water, which is H2O. I think all of us will know the set symbol of water. You can't tell me water is a gas. It can be a gas if it is under steam. But you can't tell me it is a solid. It can be a solid under what? Under ice. That means the water undergoes all states of what? Of matter. It's a specific element, specific substance. So it's very good to note that. Let me put it here, up here. Water